problem is simply a multiplication problem. That's it. There's nothing to solve in this first problem because it's not an equation. It says 12 times each of the two things that are in parentheses. All right, so your first step here is to take 12. You're going to use your distributive property. You're going to distribute 12, so you'll get something that looks like this. Anytime I have a numerator or denominator with more than one term, I always put it in parentheses. It's always the first thing that I do when I look at a problem that has fractions in it. Okay. So the first thing I'm going to do is I'm going to distribute this 12 and multiply each one of these. So 12 times x plus 2 all over 4. I might as well just keep it in the numerator and just write one big long fraction bar. Take away 12 times x minus 1 all over 3. Okay. So that you can see here that I distributed the 12 times each of those fractions inside. The next thing I'm going to do, and here's where you have a choice. You could choose to multiply 12 times x plus 2 and then negative 12 times x minus 1 if you wanted to, and then simplify your numerator. But I can see right now that 12 over 4, since this is all multiplication now, 12 times this stuff in parentheses divided by 4, I have a common factor of 1 here that I can reduce this and make my multiplication a little easier. You can either reduce at the end or at the beginning. And often with algebraic expressions, it's easier to reduce as soon as you can. So in this case, I'm going to do 4 goes into 4 once, 4 goes into 12 3 times. So my step here is to reduce prior to simplifying. And here 3 goes into 3 once, 3 goes into 12 4 times. So now this equals 3 times x plus 2. So notice no more fractions. Take away 4 times x minus 1. So now this is just the type of problem you might have had back in an introductory algebra class. You distribute the 3, you get 3x plus 6. And then the main thing here is to put a little star above that subtraction, because when you distribute, you can either say 4 times x, take away 1, and then remember you have to subtract both of them. Or you can call this a negative 4, because subtracting 4 is the same as adding a negative 4. And now if you say negative 4 times x and negative 4 times negative 1, you'll remember to change both of the signs. So if there's a mistake here, it's often right there. Sometimes people have a minus. So this becomes 3x. If I group my like terms right beside each other, I get negative 1x plus 10. Any questions on that? Okay. All right, so for the 2 people that said, I don't know, are you clear now? Okay, all right, good. That's the good thing. All right, and then Kim was kind enough to work out the second equation for us. Again, she distributed the 3, multiplied both the x and 2 by it, got 3x plus 6. And then notice the big key here, the big critical point. And you'll see something like this on your first test, guaranteed, and probably your first quiz on Monday, is where you have the subtraction out here. And like if this is worth 6 points, if this subtraction sign here or this negative 5 does not get distributed and you have like a minus 20 here, it throws the whole thing off. So that's usually like almost half of the problem right there in terms of points. So if you haven't like overcome that idea yet, you may want to make little like stars like I do to remind yourself, so when you look back in your notes. So it's negative 5 times x and negative 5 times a negative 4. And the reason I get to say that is because each of these subtractions can be changed to adding the opposite. And that's how you can get away with calling that a negative 5. So from here, I think everybody did pretty well on this, so I'm not going to take the time. Does anybody have any questions on this one? Can I move on, okay? All right. Now notice, the answer is the solution set, and this is what most of us are used to doing, just saying x equals 3. But on my math lab, every every solution to an equation is part of a set of numbers. Sometimes it's simply one number, like in this case. So for my math lab, they ask you for the solution set, which means just take the value for x here and put it between the curly braces. On a quiz or a test, um, uh, either of these is fine. Okay. Most of the time I have solution set is, if you just say 3 without the, well, if I have this written down, put it in the curly braces. If I just ask you to solve a question, an equation, that's fine. Okay. All right. I'm more curious about how people approach this without talking to me, because some of you asked me about this and I talked to you about it. I'm more interested in how you approach this problem, because we're going to start today's teaching demo off with this. So would someone share, or a couple of you share with me or with us, how you went about solving this? You found the lowest common denominator? Okay. And how did you find that? Oh, I see. Okay. So find the lowest common denominator. And you found the lowest common denominator, so I'm just going to write Kim here. You found the lowest common denominator for the two fractions on the right side. Is that correct? Okay, so you approached it by finding the common denominator, and so you made both of these here into 6, right? Okay, so I'm going to, again, first thing I always do, parentheses, parentheses. This is a really good habit to get into, especially if you're going to be ending up multiplying the numerator by a number or a negative number in particular. You'll make sure you get both of these terms inside each numerator. Okay, so what you did is you changed this second fraction by multiplying the top and bottom by 2 over 2, which is the form of 1, which is legal. So Kim has something that looks like this: 1 over 6 plus 4 minus 2x over 6, yeah? Then she added these two fractions, and she got 5 minus 2x over 6. I want to stop right here, because this is really, I would say that in terms of our overall education, in math education, like through K through 12, and then when you get further on, we don't work a lot with having students recognize proportions. So right now, this is a proportion, and there's a really easy way to solve it. Remember, a proportion is just two ratios that are equal. So every time we say something like 1/2 equals 2/4 as a true statement, that's a proportion. So if you get one single fraction on the left side and one single fraction on the right side, your job is pretty much done, because every single proportion can be rewritten as another equivalent equation by what they call cross products, multiply. A times D is equal to B times C. Anytime you have an equality between two fractions, this will always be true. So one way to simply do this problem now is just use the cross products idea and say 6 times x plus 1 equals 4 times 5 minus 2x, and then solve it from there. Okay, I'm not going to do that part. Okay, so that's one approach. And now, Kim, you said you recognized after you did all that, that you could have done something else. What would have been the other approach? $24. All right, so, right. So let's find the lowest. I want to show you how to find the lowest common denominators with numbers, so that when we come to the algebra, you'll see some kind of comparison. So one of the ways that you probably, I mean, we don't really need to do this with numbers, because we can say a common multiple of 3, 6, and 4 is 24. Gabriel says, well, the smallest is 12. And with numbers, you know what? It doesn't really matter that much whether we say change everything to 24ths or 12ths because we can reduce them in the end fairly easily. But when everything on the bottom now will be algebraic expressions, it's going to be really important to find the smallest multiple. Okay? So let me just show you the process, a process you could use. One process is to prime factor. You remember those days when you prime factor every number, because every number can be written. This is an amazing thing, really, if you think about it. Every single number, a composite number means you're not prime, can be written as a multiplication problem of primes. Like, why does that work? That's like, no matter how big the number is. And 3 itself is prime. So notice I have two colors here. So my smallest common denominator, but sometimes I call it a multiple, and I'll tell you the distinction in a minute, is only going to have two colors in it. It's going to have a pink and it's going to have a 3. I mean a pink and a blue. Sorry. But the question is, how many 2's do I put in? Well, if you put all 3 2's in, 2 times 2 times 2, and 1 3, you get the multiple 8. If you put the whole shebang in, 4 times 6 times 3, you get 72. Well, how do I get the 12? Well, one way to do this is to visualize. Here's your first denominator, 2 times 2. And I'm gonna snag one of those 2's to make my third denominator, my second denominator right here. So do you see that I have my 4 here? I have my 6, and do I have my 3 anywhere? Right there. So the multiple, the smallest multiple is simply, they share that 2, so I don't need to put another 2 in, is to simply just multiply straight across and get you 12. Okay? So the lowest common denominator is 12, the lowest common multiple is 12, so why am I changing this wording here from denominator to multiple? And that's the key to today's class. If you were adding, I'm going to cover up, let's see if I can remember how to do this here. Oh, I think the shade covers everything up. Let's see if I can get a shape here. Just cover up this right here. And now can I fill that shape? Oh, I think I'll use a heart instead. There we go. So suppose I didn't have an equation, but I was just asked to add these things. Remember we talked in the first and second class that to add anything in mathematics, doesn't even have to be an algebra class, things always have to look like. So if I was adding or subtracting these two things, I have to make common denominators, LCD. However, now I have an equation, and you have a really powerful tool that makes life a lot easier, believe it or not, to solve this equation. Yes, I could change every single one of these to 12ths and do a similar thing that we did right here with the 6. Or I could say, with an equation, I have a couple of rights, like the Bill of Rights for equations. I can add the same quantity to both sides. I can subtract the same quantity from both sides. I can multiply both sides by any non-zero quantity and divide both sides by any non-zero quantity. And life, believe it or not, comes out to be much easier if you think about multiplying by the multiple, the smallest multiple. So let's take a look at this. This is the very first teaching demonstration. So today we're looking at linear equations. Right now we're looking at a linear equation, but it has a fraction in it. Fractions in all 3 pieces of it. So I think we all agree it's a lot easier to solve a linear equation with no fractions because we tend not to feel too fondly about fractions. So the idea here is get rid of those darn fractions, clear them away. So the way we do this is we find the multiple of all of the denominators, and in this case we've already found it. So the lowest common multiple is 12. And what we're going to do, again, step 0, before we even get there, is to put little parentheses around those numerators, okay? So put your parentheses in because the book's not going to do it for you and my math lab's not going to do it for you. So now I'm simply going to go in and I'm going to multiply each algebraic expression on each side of the equation by 12. I literally put, and notice it's not 12 over 12. I don't have to worry about it being a form of 1, like when I'm adding and subtracting, because I'm multiplying both sides by exactly the same number, and that's allowed. This is a really hard habit to break. This idea of wanting to change everything to the same denominator. And it will take you a little while to be convinced that it's much easier. So my first step, step 0, is to put parentheses around all my numerators that have more than one term. Then I find my lowest common multiple, and then I stick it in as beside each one of my pieces of my equation, which we call the terms on both sides. And now I use my distributive property and I multiply each term on the right by 12 and on the left by 12. Okay, so we get 12 times 1/6 becomes a 2. And the way you can see that is either multiply 12 times 1 and divide it by 6, or just reduce it before you even start. 2 times 1 is 2. 3 goes into 3 once, 3 goes into 12 4 times. So you get 4 times 2 minus x. So that's my right side. My left side, the 4 cancels into the 12 3 times, and you get x 3 times x plus 1. So notice you have become the master manipulator here. You've chosen a number that each one of these denominators divides into evenly, because that number is a multiple of each of these. So you have now changed this equation to have common denominators. Believe it or not. What is the common denominator? 1, which is what you like to see. So from here, we've divided out the common factors in each side, and now we can just finish this problem by using the distributive, whoops, that moved on me, by using the distributive property. 3x plus 3 equals 2, and we don't even have to worry about a subtraction sign right there. It's an addition problem. We're going to combine like terms on both sides. The left side's all set. The right side becomes 10 minus 4x. And now we're going to solve for x as we usually do. So I'm going to add 4x to both sides and subtract 3. X is 1. So our solution set is 1. Okay. Any questions on that? All right. Now we can solve it by checking it by plugging it back in, but I'm not going to take the time now. Okay. So we've just solved we call these things rational equations, because anytime you have equations that it was a rational equation with constants in the denominator, again, remember, rational means you have ratios of what you think of as fractions. Now we learn how to solve rational equations that look like this. So now notice they're no longer constants. Each denominator is some kind of algebraic expression. But no need to get nervous. The idea is exactly the same as what we just did. Okay? So to solve these equations, we're going to multiply both sides of the equation by the lowest common. It's a multiple. You're going to call it a denominator because that's what you're used to calling it. I think it sets you up for a little bit of a fallacy that you think you have to make common denominators. So you'll hear me say the lowest common multiple. The big difference is we've got to be concerned about what value of x is going to make the denominator 0. Because if we go through all the work to solve these equations and the value of x is a value that makes the denominator 0, then what that means is you have an equation with no solutions. So this is a really hard thing to do, but you have to remember every time you try to solve one of these equations where you have variables in the bottom, your first step is to determine what's going to make that denominator 0. Okay, well, the first fraction here is easy to look at. You can tell what value is going to make that denominator 0. What value of x is going to make this 0? 0. So we couldn't have 0 for an answer. Now the next one It's really hard to tell until you have everything factored into its prime factors. What we just did with the numbers, the 2 times the 2, the 2 times the 3. Now we have to do it with algebra. And again, I can only continue to remind you, put GCF on your palm, because that's the only way you're going to probably think of both of these answers. So you take that little expression and you say, when does this equal 0? It's a multiplication problem. It looks like this. When does A times B equal 0? X is acting like the A and B is acting like X minus 1. Well, when X equals 0, we already have that. And when X minus 1 equals 0, which will be when X is 1. So the two excluded values from the possible solution set here for this equation are 0 and 1. Okay? If you do all your work and you come down and you get X equals 0 or X equals 1, you say no solution. Empty set. There's no number in the world. Okay, so let's take a look. When I start these problems, the first thing I'm really going to do is I'm going to factor every numerator and every denominator. That's the first thing I'm going to do. And if it helps you to put a 1 under the 5 for the denominator, do it. All right. Oops, I wrote that wrong. It's X times X minus 1. All right. There we go. All right. So you factor everything, then you find your excluded values, and now you're all set to find your lowest common multiple. So I'm going to put my different prime factors in different colors. So X is one prime factor. I'm going to make X pink. So this is going to be pink. Is X minus 1 different than X? Yep. So that has black. All right. So now I make my little circles over here. Here's my first denominator, X. To get my next denominator, I need to borrow that X and times it by X minus 1, which was supposed to come out in black. There we go. Okay. So there's your multiple, X times X minus 1. I don't need two X's. I don't need two X minus 1s. X times X minus 1 is a factor of a multiple of X, and it's X times X minus 1 is its own multiple. 2 is its own multiple, because you multiply 2 by 1, you get 2. So now this is the part that's different for you. Instead of changing everything to have this in the denominator, you multiply each and every one of these fractions by the LCM, X times X minus 1. And so you're going to put that in 3 times because you have 3 parts. Okay, so you can see all of the pieces of the original equation in blue. Here's the original equation. And what I've done is I've snuck in beside each one. It's cold winter night, trying to snuggle up beside each one, and I've multiplied each one by the LCM. Right? And at first it looks like, it's a lot, it's visually very noisy. However, now you get to reduce each piece of this equation on each side by finding the forms of 1, the fancy forms of 1. So in this very first fraction, that denominator that has an X in it has a partner upstairs, another X, and that becomes the factor of 1. So all you're left with is X minus 1 times 1, which is X minus 1. Cool. I'd rather look at that than look at a fraction. Now take a look at my second term right here. The entire denominator here is being multiplied by itself. That's even better. Now that both of these factors here will cancel or become 1, and so you're left with 1 times 1, which is a 1. And now on the right side, you already had 1 in the denominator, so you've got to multiply 5 times X minus 1, which is 5X squared minus 5X. Okay, because what I did is I put the 5X out front, and I multiplied 5x times each term. Any questions so far? Anything at all? How am I going to go from here? Anybody want to help me with this? What would you do next? Right, what? So I can drop the parentheses on the left side, right? They're not doing me any good. Right, that becomes a 0. My -1 plus 1, those are opposite. So I get x equals 5x squared minus 5x. Yep. Anything else? Now what am I going to do? That's perfectly legitimate. It's just not going to get you anywhere if you add 5x to both sides, because then you have x's on both sides of your equation. So we want to get all our x and x squared terms on one side and the number on the other. So what can I do here? Let's subtract x from both sides. Subtract 1x. And this is where, your hand gets shaky. You don't know what to put on the left side. What's represented by this? A 0. And believe, poor 0 doesn't get any credit. People don't like putting 0 in. It's a legitimate number, just like if there was a 10 there or a 20. All right, and on the right side, we get 5x squared minus 6x, because we have -5x and -6x. And the only way we can solve this equation, this is a baby quadratic equation. Remember I told you, put it on your palm, GCF. What's the greatest common factor to 5x squared minus 6x? The only thing they have in common as a factor. Here, I'll write it out longhand for you. You see anything common to both of those? X. So that's your greatest common factor. So you have x times 5x minus 6 equals 0. You've made that equation into a multiplication problem equal to 0. Now you have a way to solve it. You say each one of those factors, x and 5x minus 6, could possibly be a 0. So x equals 0, but you can't use that. Why? Because we excluded it at the beginning, because if we put 0 in here, we'd get 1 divided by 0, which is there's no number that defines. And so hopefully the only thing we have left for our possible solution is to set that factor equal to 0, which is just a baby linear equation to solve. So here's our solution. Now, if I had time, I'd go back and check it, but I want you to have a good half an hour to work on your class activities. So the process here, folks, remember, is find that lowest common multiple, multiply every part of your equation by it, find your factors of 1, and then solve the remaining equation. Don't forget to put your excluded values right at the beginning. Okay, so you'll have quite a bit of time now to work this on your own. Get some help from me or whoever you're working with. And what's happening on Friday again? I forgot. Did you? Projects are due. What time are projects due? 8:40.